Hello everyone, welcome to the last tutorial of our course, Cartographic Visualization in GIS year 2025. Over the past weeks, we have covered different topics, working with maps. We learned a number of tricks and tools and libraries, how to create different kinds of visualization, geospatial visualization using Python. So today we have our last week, and today we are going to work with interactive maps. So we learn a couple of new libraries and a few tricks how to visualize our geospatial data interactively. So we have two files that we will go through today, interactive visualization with Python 1 and 2. The main reason we have divided them into two files is that it is just heavy because we are working with interactive visualization, so the files tend to get heavy, and JupyterLab doesn't like that. So yeah, so let's start with file number one. During the class we have talked about how important interactive visualization is nowadays. We have talked about how things have changed. We are working, the world is more dynamic and expectations of our users are different. We do different things with our visualizations. So there's a growing need to make things interactive. And it can enhance engagement. It can make the data more accessible because they can browse it in a more interactive way. The users, and it has its own benefits. It allows the users to explore the data more dynamically, which is again another good thing that can improve the accessibility of data for the users. And it's also very useful for real-time data representation. So nowadays we have a growing range of data sets, many of which are geospatial, that are produced in real time. So if you want to create a visualization of that, having an interactive visualization that can connect with the data in a real-time uh, way, that can be useful. Interactive maps can be particularly useful for temporal data, and that interaction can come in different ways, and we will see that. One thing that we discussed briefly last week in week 3 was different kinds of animations, and our guest lecturer showed you examples of how you can make different kinds of animations to show the temporal dimension in your data. So if you have a phenomenon that is changing over time, animation can be useful. So animations are not always interactive, and that is something we saw in the class, but they can be also interactive, and that is something that we are going to try today to make an interactive animation. You might want to include different mechanisms to do time-based filtering in your visualization. This visualization can be cartographic, meaning that it's a map, or it can be non-cartographic. For instance, you will have a chart that you can interact with, and for example do time-based filtering. And also layering temporal data. Interactive maps can layer data from different time periods, allowing for direct comparison and deeper analysis, and that can be useful for our visual analysis. The libraries that we'll be working with, of course, we will continue working with the libraries that we have been using for a long time. So Matplotlib will be very present, of course, GeoPandas and Pandas, and those basic libraries that we work with when using Python for GIS. But in addition, we will work with two libraries specifically that would help us achieve some of the things that I just briefly presented. So the main library we will learn about today is Plotly. Uh, uh, Plotly is a very powerful library. If I'm not wrong, I guess it was originally developed by a team from Uber, so it was a commercial product, or was meant for commercial purposes, but nowadays it has been made open source. So I personally like this library. It is easy to work with, and it helps you to create very nice looking interactive maps with little amount of effort. The second library we will look at but not really get in depth with is Folium. Folium is another good library that helps you create visualization, interactive visualizations using in Python environment. It is working with, it is based on Leaflet. So it's originally JavaScript, but through Folium you will have a Python interface into the library. And again, it allows you to make very nice interactive visualization. So we are going to use Folium, but not get in depth. And the reason is that we have covered this library in a good amount of detail already in Automating GIS Processes course. And we have the link to that page, that lesson here. So for many of you who have taken that course, Folium is familiar, and that's why we are not getting into details. So if you want to learn more, and if you have forgotten or you have not taken that course before, just follow this link and learn more about Folium. It's a powerful Python library for making interactive visualizations. But let's move on to our practical part of the lesson. Okay, so in the first part of our tutorial, we want to work with wildfire data. It's an open data set that we have collected or acquired from NASA website. And we are going to use a number of different libraries and visualization methods to create interactive maps to explore different aspects of our data. So the data is temporal, so we know when a fire has happened in what part. So we have spatiotemporal data here that we will be working with, so it's kind of new in this course. So let's start with our with importing the libraries we need. So we are importing a number of things that we need for things to work in Jupyter Lab environment. So it's not core part of our code. But here we start. We import pandas and Plotly Express, which is a sub library of the Plotly library. Before I continue, I will okay, let's get started and I will get back to something that I want to actually show you. So let's load the data. The data is already saved in CSV format under the data directory. It's called fire data for map. It's in this folder. I'm going to read that data and look at the head of my data to see what kind of data I'm dealing with. So the data is very simple. We have the latitude and longitude, and also the acquiring date, or when the fire probably has happened. So yeah, so we have the month, day, and year of the incident. So one of the things that we talked about last week mainly and continued discussing this week was the use of non-cartographic visualization for visualizing certain aspects of geospatial data. So here we will quickly look how we can use Plotly to create interactive plots that are not necessarily geospatial, they're not cartographic, but they can help you explore the data interactively. So Plotly is not only for making plots, is not only for making maps. As you can guess from the name, you can also make different kinds of plots and charts in an interactive way using Plotly. So first thing we are going to do is to create an interactive histogram to show the distribution of fire occurrences. For example, we know histograms are very useful to explore the distribution of data, or if you want to do a classification, a histogram can give you a good idea how the data distribution is. So now let's just so there is a function built into Plotly Express called histogram that it works very simply. So it's very similar to what we have seen previously, for example, in Matplotlib. You just provide the data you want to work with, and then here we are using the column that you want to use for visualization. You can add the title, a label, and then of course this histogram, so you should specify the number of bins. I'm going with 120. That seemed to work well with our data, but you can change this and try different things. And yeah, and of course you have control over coloring, and you can specify things about the figure itself. So let's run the cell. It works very quickly. So now you have a histogram that is interactive. It was created very quickly. So you have the well, it's a histogram, so you have the frequency of occurrences on the y-axis. On the x-axis, we specified that we're going with dates. So here we have the dates, different years, and the number of incidents. So you can see there are peaks, for example, in year 2018, around May and June this summer, we have had more fire occurrences. And here you can see the distribution of data. Of course, you can analyze this, go to depth, but you can see we have peaks in summer, which makes sense, and we have less occurrences during colder months of the year. So we have a tooltip. If you check out the library documentation, you can see how you can customize all these things. But by default, you already have a tooltip that works nicely, shows you the value and the count. Plotly comes with this toolbar up here that gives you a number of functionalities. So if you want to get a screenshot of the chart, or you want to like just explore it a little bit, you can do that fairly easily using Plotly interactive visualizations. So that was one visualization. We can see the distribution of incidences, the distribution in our data, and the temporality is quite well visualized here. But let's continue exploring our data using non-cartographic visualization. Next, we are going to create a box plot, which is also known as a box and whisker plot. This is an excellent tool for statistical analysis and data visualization, particularly when you want to understand the distribution, central tendency, and variability in your data set. So it's also very useful if you want to identify outliers in your data. So let's just run this cell. There's a function, again, very similar to what we did up here, coming with called box, part of Plotly Express library, and yeah, so we just specify what we want to visualize, what is the color, what labels we are using, and some visualization updates for the overall layout. So one thing we are doing up here, we have date and time, so we are making sure that this is recognized by, well, we are extracting the year and months from the data, and up here we are making sure that it is recognized by Python as a date-time format. And yeah, so we are working with, so we repeat this every time, quite many times. We don't have to, but we are basically every time we are making the visualization, we start fresh. So that's the reason. But otherwise, we could have just done this and save it and just continue using it. But we wanted this tutorial to be made of like kind of independent parts, and that's why. So this is the box plot we got. So you can see the distribution. You can see the range of data. You can see if you have, for instance, outliers, values that fall very off from the box, you can see them. So this is a box plot, and this is another useful way of exploring your data. Yeah. So one thing I forgot to mention is that here we are grouping our data based on year and month. So what we are visualizing is historical changes in number of fire incidents in May. So based on our data, which is from a number of years. So this is what you get. So historically, you can see we have a peak around summertime, like in May, June, July, August, it's more, and in colder months, we have fewer occurrences. So another thing we are going to create is a time series. So we are doing the same thing again, making sure that the datetime format is recognized as datetime in Python, and we are doing the grouping, and this time we are creating a time series using a line chart in Plotly. And again, you can see there's a function for that, and it works very similar to other functions. Again, you have an interactive plot that you can work with. You can zoom into different areas, zoom out, and you have the same toolbox again. So these are different ways you can create charts. If you check the documentation, there are many types of charts. So Plotly is not only for making maps. If you need to make nice looking interactive charts and plots for your data, Plotly is something you may want to consider. So, okay, so this was the non-cartographic way of visualizing our geospatial data, the temporal aspect of it. Now we want to create a map that also shows that temporal dimension. Of course, you can try to make these with non-interactive methods, but you know it's a bit of a challenge with with temporal data, showing that temporality in a right way using static maps. That's why we are using an animated map. So we are creating an animation that shows how well how the occurrences change, how they happen over time. So for that, again, I'm using Plotly Express, importing the data again. As a first try, I'm going to just make a point map. So I'm just using the function scatter geo from Plotly Express to create a quick map and adding some visualization details, for example, centering my data, my visualization on Finland. I've added the coordinates for Finland manually, and you can specify the marker size. One thing to note is that if you want to specify the marker size like to a fixed number, you have to do it from outside this where you define the fig. And the reason is that if you specify the marker here, you can specify a column that will adjust the size of your marker. So if you have a column with values and you want the size of the marker to be proportional to the value in that column, then you can do it straightly here. But in our case, I want it to be just a fixed size for all points. I'm setting it to size 3. That's why I have to do it from outside using the figure and updating the traces in my figure. So that's one thing to note. The rest is simple, just specifying like where to center and doing some layout updates and adding a title. So let's just run this and see what we get as the output. So this is a very simple map. We're going to continue working with this. So this is a dot map showing the occurrences, and it's not visualizing the temporality at all. It's just all the data, just based on their locations. So this provides a quick overview of the data, which is good for starting with, but it's not enough. So we want to also work with the dates that we have in our data and make an animation based on that. So I'm going to load the data and repeat the same thing. I didn't have to do it. I've done it up here, but doing it again here. And then I'm creating my scatter geo again. I'm changing the projection here to a conic conformal because we're working in Finland, and you know Plotly is working on the globe. So here actually the map we see it, we have zoomed it on Finland, but it is actually a global map. If you zoom out and interact with it, you can see it's a global map. That's why, so that's the limitation of Plotly, but that's how most interactive libraries work on a global level. So to make the map look okay, so to make the shape of Finland look all right, I'm using a conic conformal projection. So that is the reason I've used this visualization. So you can explore with different projections and see, of course, do your research and see what works best. For example, here we have tried the azimuthal equal area to preserve the, that helps us, well, it's good at preserving the areas. So there are different ways you can do this, explore different projections and see what looks best, but let's continue with this one. So we created a scatter geo, our point map using the scatter geo function that we had already seen. I'm then making some updates to this. So I'm applying the center, same value, somewhere from middle of Finland. The zoom level, so I'm going to set the zoom level. Then there are a number of features that you can specify in Plotly. So if you want the coastlines to be added, you can just set it to true and specify color. Do you want to show land? Do you want to show ocean, lakes, rivers? So you do not necessarily need to import or visualize separate layers of data if coastline is what you want to have in your map as a base map. Then you can just set it through. There are more things you can specify here. If you check out the documentation, you will see them, but there are many things you can just fairly easily add to your map. For example, you can show rivers to true, set show rivers to true, and have rivers added to your map. I'm updating the size of my visualization, the dots in my map, and some extra layout adjustments. One thing that we have commented out here, but you may want to use this, for example, for your portfolio, or if you want to like share your work on a website or share with people as HTML file, then you can just save it using Write HTML, similar to what we have done previously, for example, with Folio in AutoGIS course. You can just save your figure as an HTML and provide the path. That's something we are going to skip now, but let's run the cell and see what kind of output we get. So this is what we get. So yep. So here we have like tooltips. So we have for hover name. So what you get when you hover over a feature, you get the acquired date. You can of course change how it is shown. We have applied color and animation. So we have added an animation here. That's one of the main points in our visualization, and that animation is based on the temporal column we have. So once you do that, Plotly takes care of the rest. So it adds a couple of buttons, play and stop. You can guess what they do, and you have a slider that you can use to browse to different times. So this is a bit heavy, especially for Jupyter Lab and Notepad. So hopefully it doesn't crash. But if you play the button, if you press the play button, it will start going through your data, and you can see the incidents, the fire incidents as they happen. Of course, if you're in a hurry, you can just drag the slider and see how things happen over time. So this is one way of creating animation in an interactive way. You can interact with the map, so you can zoom in, zoom out. So it's not an animation like a GIF file or video, but an interactive map you can interact with. You get still like pop-ups and tooltips, and you have a slider that you can interact with the temporal dimension. So that's a nice function from the Plotly library. Now we are going to make the map a bit more useful. So if you just look at this, okay, this might be enough depending on what the purpose of your map is. But in some cases, it may not be enough. So if you just look at the points, you may want to aggregate your data on a bigger level and then have aggregation. So you might be interested in seeing what kind of, how many fire incidents you have per different regions in Finland. For that reason, that's another kind of useful map. So this is what we're going to do next, aggregating our data based on regions. So I have gotten we have the shapefile for regions in Finland, downloaded from Python. It's already saved under data. And I'm going to read this file and save it under a variable name Finland regions, and make a quick plot to just get an idea what we are doing. So these are the main regions in Finland that we are working with, and we are going to aggregate our data to these regions to get instead of visualizing the individual incidents, we will visualize the counts of incidents in different periods of time per different regions. So this is what we are doing now. So first we have to take it to the right CRS so that we can visualize it in our global map, which is working in a global coordinate system. Reading our fire data, again, working with the date time and converting it to a data frame, something that we have done before, but starting over here for this part of visualization. And then here we are doing the data aggregation. We are doing join and doing data aggregation. We are doing a special join. This is something we have learned about in AutoGIS course. So if you have forgotten how this works, please check out the link here. So that's the aggregation part of our calculation. Next thing we are doing is to apply a classification. Classification is not explicitly part of cartography, but it is a very important part of cartography, and we are going to talk about this in week 4 of the course. For our purpose, I'm going to use natural breaks using map classify library that we have extensively worked with in AutoGIS course. Again, there's a link here if you want to check out those materials. Yeah, so I apply the visualization, and this time what I'm doing is I'm creating a choropleth map. So I'm not creating a dot map anymore, so I'm not using a scatter geo. There's another function called choropleth coming part of this Plotly Express library that allows us to create a choropleth map fairly easily. So what I'm doing here is I'm providing the aggregated data I've calculated. I'm also adding the Finland GeoJSON that we created up here. That is the borders of Finland. It has to be in GeoJSON format, so that's why we have done this. We have done the conversion up there, and then so it works a bit similarly to Folium. It does a join. In this case, we have multiple data layers. So based on the name fin column in the two data sets, it performs a join and then shows you the visualization. We of course have the animation, and this time we want to use the year values to show the animation to keep things simple, and we can specify the scope of a map, so it's Europe, and add a title and labels and adjust the colors and so on. So let's just run this and see what we get as the output. So this is a big library. You have a lot of control over what you can do here. Well, I forgot to run this cell. Let's run this one first to get our aggregated data. Now it's our data aggregated per region, and then you have number of incidents for different years. So now let's run this again. We should get the output. Yeah, so if you check out the library, you can see a lot of information, how you can further customize your visualization. So here we have the map. So it's an interactive visualization. You can see the number of fires per region in different times. And again, you have the slider that is going through each year. So one thing that I don't like here is that, well, in some years, we do not have any fire incident in certain region, and they disappear from my map. And that is not ideal from a cartography point of view. So for example, here at the beginning, is it 2012, I guess? So this eastern parts of Helsinki, Finland disappear because there has been apparently no fire incident that year from that region. So this is something that does not look good. But otherwise, I like this. We have a tooltip. We can browse your data. We can do different things. And you have the slider, so you can explore the dimensionality of the data. Yeah, so another thing we are doing here to make our map nicer is that we have zoomed over Finland, and you can see that we can make the rest of the area. So now that we are focused on Finland, we can make the rest invisible, which is nice. So it allows, so it's a global map in essence, but it allows you to focus on the study area, which is Finland in our case. So we want to have more consistent region visibility, even if there is no incident. And for that, we are adding basically another overlay. So we are adding the data. So we are visualizing, well, we have the map we had, but at the same time, we add the layer of Finland borders, like the region borders again. So it will be there as a overlay. So even if there's no incident, you will see that other layer showing the regions of Finland. So this is what we are doing to get a better map. So this essentially is the same thing. So we added that border again using a scatter geo. So we are visualizing the lines separately. So now this is added. So even if we don't have any incident from the year 2012 from this region, they still appear on my map, and that looks much better. So this was the first part of tutorial. We are continuing in the second file with the interactive visualization. Okay, so let's continue with the file 2, interactive visualization Python 2. During this course, a couple of times we have talked about combining cartographic and non-cartographic visualization. We talked about this a few times, specifically on week 4. And now we are going to try one way of doing this using interactive visualization. So we would have, like, there are certain things about data that can be visualized nicely using a bar chart, a histogram, for instance. So when we're looking at the temporality of the data and how it changes from year to year, we saw that charts worked very nicely. Well, the maps are nice to show, are useful for showing them geographical distribution. So how can we benefit from both? Well, one way was to create those animations that we already did, but how can we create, how can we have both in an interactive way? So one way is to create charts and embed the charts in our map, and that is something that we are going to try now. So you have different regions. When you click on the region, a pop-up will appear with a chart in it, a bar chart that will show you how the number of incidents have changed over years in that particular region that you clicked on. So this is what we are trying to achieve now, and for that we are using Folium. Folium works nicely with this kind of maps. When you have a lot of control over the pop-ups with Folium, you can write HTML, you can do different things. So there are a lot of possibilities. So what we are doing here is that, well, we are loading the same data, we are loading the regions, we have the aggregated data that we created in the last part, so aggregate here, so we are not recreating that, working with the same CSV file as the first part of the lesson. Then I'm creating a Folium map. As I said, this is a library we worked with extensively in the AutoGIS course, so view those, check our website from that course to remember how it works. So yeah, so I'm going to use Folium for that. One thing I'm doing is I'm creating a function for plotting bar charts, because I'm creating plots for different years for each region. So I don't want to rewrite the code. Instead of running that code, like writing that code separately for each region, I'm going to create a function. So for each region, I can call that function and create that bar chart that I'm going to add to my visualization. So we have seen how to do this. So I'm just using simple matplotlib to create that static bar chart of my data. And I'm going to save it as a figure. So you can explore different ways, but when I was doing this, I did a bit of research, and it turned out that it works best as an image. So if I'm embedding, it's just less complicated. You can try to make it HTML or make it interactive, but seem to be difficult. But for our purpose, it's enough if it is a static chart, because the map itself is already interactive. And I'm going to save it as part of my function when I create the bar chart that we have learned about already in first course, GeoPython. Then I'm going to just save it as a figure, and then I'm going to just embed this figure. I return the path to the file, and I'm just going to embed that figure in my pop-up. So that's what I'm doing. Then the next thing I'm doing is I'm just adding it to my pop-up. So with the pop-up content, I call this library, call this function that we have created, and that will allow us, so we are iterating through our features and calling this function every time, getting the chart out and inserting it into our pop-up. So the image we get, the pop-up content will come from the so it's essentially the path to the image we created. So let's run this and see what we get as the output. Okay, so this the looks are not optimal, like the extend the size on Jupyter Lab, but if you just export this as HTML and we view it in full screen, it will look nicer. But this is what we get. So we zoom in, we can zoom in, zoom out. So you have the functions coming from Plotly, from Folium. But what we have added here is that we create a chart using that Python, so incidents in Lapland. So you have this chart, but if you click on different areas, you get this pop-up. That chart shows the temporal distribution of incidents in each of these regions. So this is a very useful map depending on what you want to do. You might want to create these maps. So here, the content in the pop-up is a figure showing the chart. Of course, you can put any figure. So if any other kind of image, any other kind of multimedia is relevant to your visualization, like we have talked about during the fourth week of the course, you can just add that image, that media here as a pop-up. So it's very good for example, creating different kinds of story maps if you don't want to use a software for that. Okay, so now we are going to explore our data using a different kind of visualization, and that is an interactive heat map. And for creating heat maps, interactive heat maps, we already saw how to create a static heat map on week 3. Now we are going to create an interactive heat map, and for that we can use Folium. There is a plugin or submodule coming from Folium specifically called heat map that allows you to achieve this. I'm going to load my data again, and then I'm going to initialize a base map, basically a Folium map, and yeah, and then here I'm creating the heat data. So you might have a column in your data. For example, if you had a column called fire intensity, you know you can account that. You can take that into consideration when creating your heat map. You know, it can be weighted by the intensity of fire. In this case, we don't have that information, so the density is purely based on where the points are located, like the density of the incident. But you had the option of adding this here if you had that information. And then you add the heat map. So you create the heat data fairly easily and you add it to your map. And then if you want, you can save it as an HTML that you can use in your website or in your report. I'm just going to run this and see what I get as the output. So it's a heat map of Åre, Finland, and it's interactive. So as you zoom in, it readjusts how the heat map is calculated based on the extent of your map. So the more you zoom in or zoom out, you can see that the visualization changes. So Folium allows you to, with just one line of extra code, you can create an interactive heat map using Folium, one of the Folium submodules. Okay, so that was the second part of our tutorial. Now we want to quickly cover a number of things. We don't have, well, we have enough for the week already, so I just quickly show you to give you ideas in case you want to explore this further. We are going to talk about this a lot in the lecture in week 4, AI and other tools that you may want to use for cartography. So I leave the details for the lecture, but to give you just some idea, this kind of graphics you can create easily. There are different AI tools. There are a lot of online tools that can allow you to do this, but if you want to create this in Python, for instance, one way of doing this is to just create separate images. So you can create different maps for different years, static maps, and to avoid repetition, of course, you can write a function, you can write a for loop and create different images of incidents in different years, for instance, and then you can make a GIF of it and include it in your website. That's the way I suggest. So if you want to create this kind of visualization as a GIF file, then you will create different static maps and then use libraries such as this Image.io to create a GIF from those separate static images. So essentially this is what it is, but there are online tools and even AI tools for doing that that you can explore. I leave the details of these for the class, but let's quickly look at publishing interactive maps. So as part of your exercise 4, or if you are using interactive maps in your final project, you will end up with HTML files. Essentially, we saw already when working with Plotly or working with Folium how you can save them as HTML files that you can share with others or embed in your website. So for HTML file to be embeddable, of course you can just share that with us in different ways, as a form, as a link, or just upload it, for example. But if you want to host the file, then show the file on your website, then the HTML should be hosted somewhere. So this can be, for example, easily done on GitHub pages. So there are instructions how you can achieve this in GitHub pages, and then you can embed it on your website. For example, if you have a WordPress website like you have in the University of Helsinki for your own personal pages, but we probably will talk more about this in the class. But here you can find information how you can embed the file in your website if you go with a weblog for your final project. Okay, in exercise 4, we are going to work with a flying data set from of flying squirrels. It's an AI generated image, as you can guess. So the data is from OSIMA. You can download it. Well, this link won't work here because it's meant for the website, but the data is in exercise 4 data, this geo package. So you can download that or just go to the original source and get more data, like more complete data, or check out the documentation. So you have to do three things. The first part, as usual, you have to write a weekly reflection of what you have learned from the discussion and lecture during the week. In the second part, you create a non-cartographic visualization using methods we have learned in previous weeks or what we learned today, non-cartographic interactive visualization of your data. And then we will have the main point, and the third part of your exercise, which has the biggest weight, is the interactive map. So make an interactive map to visualize your data, and you have free hands how you want to do it, which aspect of your data you want to explore. And the deadline for this is 5th of June, and this will be our last exercise. Of course, you will have the final assignment to work with.